This lesson is on solving equations with rational coefficients. So two numbers with a product of 1, such as 3/4 and 4/3, are called multiplicative inverses or reciprocals. Reciprocals are what we're going to use to solve our equations. So first of all, we need to review some vocabulary. A coefficient is the numerical factor of a term that contains a variable. So in my example of 3x, 3 is the coefficient. That's going to be important to remember. Now, when we are solving this equation, 3/4 c equals 18, we want to get the c by itself. So I always like to block off my equal sign. And now I'm going to use the reciprocal of 3/4 to solve for c. So I'm going to multiply by 4/3. If I multiply by 4/3 on one side, I need to multiply by 4/3 on the other side. Now I can cross cancel here to kind of simplify this down. 4 goes into 4 one time, so both of those cancel to 1. 3 goes into 3 one time, so both of those cancel to 1. So all I'm left with is 1c. Now on the right side, I'm going to turn my 18 into a fraction by putting it over 1. And then I can cross. So 3 goes into 18 6 times. So this becomes a 6 here. And then 3 goes into 3 one time. So now I can just multiply straight across. 6 times 4 is 24. 1 times 1 is 1, so we don't need that 1. And we're left with 1c equals 24, or just c equals 24. With every equation we have, we can always check our answer. So I'm going to check our answer here. First, we need to write the original equation. The original equation was 3/4 c equals 18. Now I'm going to replace c with 24, which was our answer. So 3/4 times 24 equals 18. And I'm going to put a question mark here because we don't know if it equals 18. We're finding that out. So turn 24 into a fraction by putting it over 1. 4 and 24 can cross cancel here. 4 becomes a 1. 24 becomes a 6. 3 times 6 is 18. And does 18 equal 18? Yes. So we have checked our answer, and the sentence is true. Okay, now we're looking at an equation that has mixed numbers. So before we can solve this, we need to change our mixed numbers to improper fractions. So multiply here, 2 times 1, add 1 up here. 2 times 1 is 2, plus 1 is 3. So we get 3 over 2s. And then 2 times 16 is 32, plus 1 is 33. And our denominator stays the same, over 2. So now I'm going to use the reciprocal to solve. So multiply by 2 over 3, multiply by 2 over 3. I'm going to get my equal sign in bars there. The 2's will cancel each other out here, and those both will become 1. The 3's will cancel each other out, and those will become 1. So I'm left with 1s. Now here, both of these 2's will cancel to become 1. This 3 will cancel to become 1, and 3 goes into 33 11 times. So 11 times 1 is 11. So 1s equals 11. We can always check our answer. Let's start by writing the original problem. 1.5s equals 16.5. Replace s with 11, which was our answer. 1.5 times 11 equals 16.5. I'm going to change this to 3 over 2 again, times 11 over 1, and we're going to see if that equals 16.5. We can't cancel anything. 2 does not go into 11. So this would be 3 times 11 is 33. 2 times 1 is 2. And we need to see if that equals 16 and a half. Well, if we look back at our original problem, 16 and a half turned into 33 over 2. So yes, we are correct. 16 and a half equals 16 and a half. Now we're going to solve an equation that has decimals as our coefficients instead of fractions. Sometimes we don't like to have the variable on the right hand side of the equal sign. We can always change it by just turning our equation. So 0.45 stays with the n and it still equals 3.15, but we just need to switch them. Now I can block my equal sign off. And if we remember, 0.45 is being multiplied by n, so to get that n by itself, we divide by 0.45 on both sides. These will cancel out. N equals 3.15 divided by 0.45, or 45 hundredths. That would equal 7. To check our answer, we rewrite the original problem. 3.15 equals 0.45 times 7. When we multiply that out, 0.45 times 7 equals 3.15. So our answers match and we are correct. Please complete these practice problems on your own. We will check them in class tomorrow.